for the specific problem that we were trying to solve. Avoid unnecessary abstraction and inheritance. Just get me to the source quickly. If I'm trying to step back through a line of code in my debugger and I want to see exactly what's going on, and I have to go from superclass to superclass to superclass, it's just tedious. Like, don't do that. So with that kind of as our baseline, as our foundation, brings us to this. And no, this isn't the name of some indie rock band. It stands for Model, View, View Model. Now, the models and views are familiar objects, but what's this whole view model thing? Think of the view model as being responsible for a display of something. That something could be a list of things or a single detailed view. It's just kind of one unit of work. At its core, you'll call methods on your view model and observe properties as they change. Other functions of a view model might include things like formatting, data sanitization, validation, and so on. One helpful thing that I found is to think of your view model as foundation objects only. If you find yourself starting to need to include UIKit, take a step back and see if you really need to do so. Things like fonts and colors, they don't really belong here. The one exception I do make is images. Can't really get away with that. You need UIKit for your UI image. So how do all these objects work together? Your view can stay in its storyboard. There's no need to create a specific UI view subclass. The only time I find a need to subclass our UI view is if we're doing animations. That helps to kind of keep things consolidated into one object as we're moving things around, adjusting scale, alpha, things like that. You still have your view controller. It keeps its regular outlets and actions. That hasn't changed. And here's where the view model comes into picture. We'll call methods on our view model and observe those changes with individual properties. And the controller is essentially the glue layer between the view and the view model. Now, I'm sure some of you are thinking, great, now I have yet another object that I need to write and maintain. Why would we want to do this? Oftentimes, while having discussions with my team, I find myself saying, we don't really care about that. And I have to catch myself, because what I really mean by this is that's not our responsibility. Let the server do the work. It's our job to show the most recent data. As Martha Stewart would say, asynchronous, it's a good thing. If we wrote something like this, it would fail code review immediately, especially if we were doing this on the main thread. We don't want to block our UI. So we know that asynchronous networking is the way to go, but how do we introduce more asynchronous behavior into our own code? As a view controller, we're trusting that the view model will get the data that we need. We don't particularly need to know how it does it, just that it does it and things change. The only thing that we really care about is that the view model will inform us of our changes and we can update our UI accordingly. So here's a basic example. Suppose we're tasked with building the login feature of our application. We have a simple UI with a couple of text fields and a button. And here's our corresponding view model in pseudocode. Let's assume that we have simple business rules and that our username and password fields must contain something, any value, before we enable our button. Since our initial values are empty, our hasValidInput Boolean property is set to false. Therefore, our button's in its disabled state. As we type into our text fields, we'll call the appropriate methods on our view model, set input for a given field. In turn, we'll call our own internal method for validation. Since we've provided a value for just our username, but our password is still blank, our button's still disabled. The user now enters a password. We'll call our validate method again. And now that our requirements have been met, we'll update our Boolean property so that it reads true, which will now enable our button. A few sprints go by, and our requirements change. Now we have something along the lines of our username must be at least 8 characters, our passwords must have a number and a special character, what have you. We've seen all this before. All we have to do to implement this new requirement is update one method, that validate method, within our view model, and our controller remains unchanged. We don't have to touch a thing, and our UI behaves exactly as we intend it to. The view models are also highly testable. Unit tests with view controllers generally don't get along well with each other. And that's typically why I find that we tend to avoid unit tests. It's hard. But by having our business logic in a, quote, headless object, it's just responsible for data, that makes something that's easier for us to test. So in a unit test case, we can instantiate our view model, set some desired inputs, and test for the output. But remember, we should also test for edge cases and our failure scenarios too. A previous example, maybe we have a password that has a valid length, or a username rather, that has a valid length, but the password hasn't met all of our requirements. So we can test all our inputs and all of our outputs and get both, positive and negative test coverage. We can be faster too. So let's revisit our tree. So the top, our leaves, they're our view. And the trunk represents our view controller, and our foundation or our roots, that's our view model. Once we've defined the contract for our view model, we've defined the schema, what are all of our properties, what are all the methods that we're going to call, we can hard code those properties and go ahead and begin wiring up our view controller. This allows us to start building a functional UI while our API integration is still in progress. And if you really need to deliver a high-fidelity prototype, you're dealing with real code. It's real UI. You've got the same timing and transitions. It's just all mock data. This design pattern also allows us to divide the work up to suit the skills of our team in our best possible way. We could have a strong UI developer work all the way across the top, or we could have each developer own a feature from end to end. Remember, our view model is a display of something. A while back, we were working on a finance app and had view models that represented both a list of accounts and a list of transactions. One day, our product owner came over and asked, well, what about the Apple Watch? Using our existing view models and replacing our view controllers with interface controllers for the watch, we had a watch version of our app up and running in about a couple of days. If we had all of this logic buried in our view controller, we'd have to rip that out and rewrite it into our new WatchKit interface controller, and it would have taken tremendously more time. Separating our business logic from UI allowed us to quickly adopt this new form factor. The same approach would make it easy for us to add support for an iPad or even an Apple TV app. And since our view models are headless, we're prepared for the day that a HomePod SDK might be released, and whatever devices are yet to come that we don't know about. And now for the more polarizing topic of today's conversation, core data. If you're not using core data, you probably should be. Without fail, every time I suggest using core data, I'm immediately met with the following counterpoints. But we don't need offline access. Or we don't need persistence. These are all valid points, but it's a good thing that core data is not a persistence engine, it's an object graph. Your outlook will change as soon as you start thinking of your objects as things that have attributes and are related to one another. Once you get your data structure solid, the rest of your app will be a breeze. When starting a new API integration, I begin to visualize the data, and I ask myself, how do all of these objects relate to one another? So I kind of start mentally building out my data model. Going back to our guiding principles, being true to the platform also means being true to your own needs. This means to define objects that make sense for your own app. Resist the urge for a magic parser. I like that one. I've seen it come up a lot. Oftentimes I hear developers, they want to save time by, oh, well, if I just mirror my JSON response and my objects here, I don't have to write parsers. Think of all the time that we just saved. It's like, well, it might be faster in the short term. I can guarantee it will lead to more pain and suffering in the future. Every time I've seen this implemented, it's always come back to bite us in the end. You'll end up with extra objects and attributes that just don't make sense to iOS and don't make sense to your app. Who else has been searching through a code base and seen properties named something like this? It doesn't feel natural. Like snake case, it just doesn't make sense to iOS. So by defining properties like product ID, product identifier, whatever you want to call it, whatever makes sense for you and your app, just stick to that. Even worse, what happens when your API updates and an attribute or a data type changes? We were expecting a string, and now we've got a number, or an attribute was renamed. Instead of modifying just a single line in our parser, we now have to make changes all throughout our code. Every reference to that one object now needs to be updated. To compound further on our problem, this issue may not be detected at build time. You've now introduced an unknown number of regressions into your code base. Have fun fixing all of those new bugs. Now let's take a practical example. Displaying data in rows in a table view. And pretty much every app needs to do this at some point. And the naive approach to this is to create a mutable array, add some objects to it, reload our table data, scroll down, scroll some more, tap a reload button that kicks off an API request, we'll parse the response. We have to loop through all those objects, make sure we don't already have it in our array, add it to the array, sort the array, reload data, rinse and repeat. That's a lot of work. Don't ever do that. It's tedious, it's fragile code, and it's expensive. Every time you call reload data, you have to recalculate your entire table layout. That might be fine if you're dealing with 10 objects, 20 objects or so. But if you're scrolling through hundreds of objects, that's really, really taxing on the system. That simple call to reload data means that we now have to tell UIKit how many sections we have in our table, how many rows are in each section, the height for each row, and we also have to recreate all of those cells that are currently on screen and return them back. So how can core data help us here? Well, since we're using core data, we need fetch requests, right? Not so fast. If we do that, we're right back to where we started, where we're manually managing arrays of these model objects. Now they're just managed objects, not plain old NS objects. Fetch results controllers here are your friend. Remember that our view models, they display a thing or a group of things. We can take this idea and express that as with a predicate in our fetch request. We might have things such as, give me all the products within a certain category, give me a product with a certain identifier, show me my favorites, what's in my cart, and so on. Even better, the fetch results controller delegate will give us fine-grained updates. This essentially replaces all of that tedious boilerplate code that we talked about earlier. We don't have to manage arrays of objects and reload, things like that. We can pair these delegate callbacks with table view begin and end updates, and adding, removing, and reloading rows there gives us all that fancy UIKit table view animations for free. We don't have to write any of that anymore. Remember the idea of adding more asynchronous behavior to our apps? The fetch results controller and its delegate allows us to react to changes in our objects as they occur. And that's the important part, it's as they occur. Again, I don't need to know how or when a change happens. The only thing I truly care about is handling those updates as they come in. Let's see it in action. We'll start simple. We'll display a list of products. Our predicate will be something along the lines of, give me all products that belong to category X. Awesome, that's easy enough. Now what happens when we tap on one of those rows? We need to show a detailed view of that product. So let's take a look. Tapping on one of those rows takes us to a loading spinner. I can't tell you how many times I've seen this. We create our new view controller, push it onto the stack. This new controller will now call an API, and the user is left looking at a loader while we're getting our new info. Let's try that again, but this time we'll use our core data stack. Since we already have what I call a lightweight version of a product object, we can immediately populate part of our UI. We have attributes such as the title, price, and a thumbnail image. This gives the user something to look at, some relevant content while we're making our API request. In the end, we're still taking the same amount of time to make the same number of API calls, but now instead of looking at an empty screen with a spinner, you've got something while we're waiting to retrieve the full version of our product. Once our API returns, our fetch results controller delegate gives us the will change and did change callbacks. And once we receive these, we can update our UI with our new properties to fully paint the rest of our view. Building upon what we've done already, Let's implement a favoriting feature. So tapping on that heart icon, it'll call an API endpoint to mark this as a favorite, and will also update the isFavorited property of our product model object. Now that's easy enough, but what about that previous controller that was on the stack? We need to ensure that it's showing the same favorited status for this project when the user navigates back. How much effort will this take us? None. Since we're using core data paired with a fetch results controller, as soon as we update that isFavorited property on our product object and save the context, our delegate and our previous controller will see that didChangeObjectIndexPath callback, and then we'll tell our table view to reload that one row that changed, and only that one row that changed. We don't need to call reload data and completely rebuild our table view. Again, that's just expensive and we're wasting CPU cycles there. So hopefully that triggered a few light bulbs right about now. Since changes propagate throughout our stack, any objects that are still in memory will see those changes and update immediately. And what I mean by still in memory, say I've got a tab bar-based application. I might have a list of favorites here. It's not on screen, but it's still technically in memory. And if the user navigates back, we want to make sure that they can see the correct data. I don't know about you, but this gives me a tremendous amount of relief thinking about how to build apps. This makes solving for complex business requirements considerably easier. I don't have to do some complicated system of having custom delegates that wire all of these controllers together, or post notifications and hope somebody listens or hears it and updates their UI. Like everything it updates as it needs to. Now let's try a more challenging feature. Every commerce app needs a shopping cart. Not only do we have a controller that shows us a list of the items in our cart, we'll also likely need to display a badge on our tab bar item. And maybe we'll even have a toast-like banner that shows our most recent change. It'll animate down from the top, pause for a moment, animate away. By having each of these features driven by their own fetched results controller, the only thing that we have to worry about is keeping our cart model objects in the correct state. Each of these will see the changes and update their UI accordingly. Everything is kept in sync. These changes might be something like I swipe to delete, so remove an item. Again, I don't need to do some convoluted system of posting a notification and having all of these things reload their data. Once I get my object graph correct, update quantities or add a new object with a relationship, everything just updates. It works. Like once we've written it once, data changes, our UI shows the correct updated data. So we've talked about the benefits of separating our business logic into a view model and how the callbacks that we get with the fetch results controller can keep our data in sync. How do both of these things fit together? How does this all work? So let's start with our basic MVVM design. View, our view controller in the middle, view model on the right, same interactions between all of the objects. Our view model now owns an instance of a fetch results controller configured with the fetch request. Our view model also acts as the delegate for that fetch results controller. In this example, let's say we're displaying information for a single product, that product detail view. Inside of our controller didChangeContent method, we can then update all of our local properties, price, title, number of reviews, rating, and so on, inside of our view model. Once those properties are set, our view controller observes those changes, and it updates image views, label text, and whatever you need. Now that we have our front end set up, where do we get all of our data? I like to have an object whose sole responsibility is to initiate retrieval from an API. I can call one method getProductById. It knows how to configure an NS operation wrapper around a URL session and puts them in an operation queue. Once we get our response, we can then instantiate a parser object to process our JSON. The parser will create new managed objects, but remember, we should also check to see if we have this object already, kind of that lightweight product object that we were talking about earlier. We can fetch an instance of that, update our properties, and save them back. Two things of note here. One, our parser is using a background context. This is helpful so that we can keep our main thread free. We've got our smooth, 60 frame per second buttery smooth scrolling. And also, the double-headed arrow there. Think of your background context as being read and write enabled. We can do both of those things. And to close the loop, since our background contexts are children of our main queue context, as soon as we make changes in the background, that main queue context will see those changes and propagate them back up to our fetch results controller. Also note that our main context here should be considered read-only. It's on the main thread. Just have that wired up to your fetch results controllers. Its sole purpose is to drive your UI. While this looks a bit complicated, it's pretty much all one-way communication. Think of it almost like a fire and forget scenario. It can create a unit of work as an NS operation, throw it in a queue, let it do its thing. When it's done, it parses its data, inserts it into our background context, save. Ultimately, that bubbles up to our UI. And again, I don't need to know the specific implementation details of how this works. Once all the plumbing is put in place, we can be guaranteed to get our updates when they happen. I'll leave you all with this. If you only take away one thing from today, it should be this. No matter what design pattern you ultimately choose, and I know we have a few architecture design pattern talks here, anytime you can introduce more asynchronous behavior, it'll be for the better. This can be simple as reducing the number of public methods in your code that return an object. Anytime you have a method that returns a value, you've essentially introduced a speed bump. You now have a scenario where your caller object is essentially blocked until you return that value. So if you can kind of decouple those things, think more asynchronous, have a block or a closure callback. Like, here, do this unit of work. I don't care how you do it, just get it done, and when it's done, let me know. I don't have to sit here and wait, hey, where's my data, where's my data? But wait, there's more. Since this is TekiCon, I'll let you in on a little secret. Here's some of my favorite tiki bars around the country. And also, I did not buy this jacket specifically for TekiCon. It did come out of my closet, so this is my formal Aloha wear. Here in Atlanta, we have Trader Vic's, that's downtown at the Hilton, and SOS Tiki Bar in Decatur. So if you're hanging around for a little bit longer throughout the week, be sure to check those out before you leave. Let's see, venturing a little bit further south, you have Trader Sam's Grog Grotto, that's at Walt Disney World. Old historic one, the Maikai in Fort Lauderdale, really great. We saw our hula performance earlier. The Maikai puts a great show on, all about the history of various aspects of Polynesian history. Continuing around the Gulf in New Orleans, there's Jeff Beach Bum Berry's Latitude 29. Definitely recommend that one. Let's see, staying on the East Coast, in Pittsburgh, Hidden Harbor, that's a fun place. For the Chicago folks in the house, you have 3 Dots and a Dash and Lost Lake. Super great, especially when it's cold and snowy outside. You can kind of get your tropical escape. And going down the West Coast, in the Seattle area, you have Rumba, amazing rum selection. I think they have over 300 different bottles of rum like in stock on the wall. It's really impressive and overwhelming. Navy Strength, that's also a good one in Seattle. And a little bit further south in Tacoma, there's Tacoma Cabana and Devil's Reef. Continuing our trek down the coast, Portland, you've got Hale Pele, amazing place. And San Francisco, of all places, this is like a mecca of tiki. Smuggler's Cove, Tonga Room, which is really cool. They've got a pool, massive pool in the middle of your dining room, and there's a boat in the middle of the moat. I just wanted to say that, boat and a moat. And there's a band that plays on the boat. It's really cool. It rains on the hour. It's a really kind of cheesy effect, but I like that. It's all part of the tiki culture. Let's see, also Pagan Idol, and there's another Trader Vic's. That's across the bay over in Emeryville. So if you're lucky enough to get an invite to Pixar, you can hit up Pixar and go to Trader Vic's afterwards. And then continuing down the coast, Southern California, another historic tiki bar. You've got Don the Beachcomber. Another Trader Sam's, this is the original one at the Disneyland Hotel, followed by Pacific Seas and False Idol down in San Diego. Mahalo for your time. Hope you enjoy the rest of TekiCon. Sorry, Jonathan. I'll see you all at the luau tonight. If you're interested in all things tech, Twitter, Turbo Tomato. that's the way to find me. If you're interested in the other side of things, the rum and the tropical cocktails, Instagram, the rum guy. I'm not ashamed to plug my own social media profiles. But yeah, if you're interested in any of those things, check them out. Thank you.